Hello, today we are looking at one-to-one exponential functions. What one-to-one exponential functions mean is if we have two exponential functions that have the same base, then that means their exponents must be the same. So in this case, it's nice. I've given to you where two bases are the same. They're both 4. So that means if both of these equations or both of these sides have the same base, that means their exponents must be equal to each other. So now we can solve this, subtract the 2x on both sides. So 3 equals negative or positive 3x minus 6. Add the 6 to the other side. That gets us 9 equals 3x. Divide by 3. And our x value is 3. So now let's go ahead and check that really quickly. And we're going to get 4 raised to the 2 times 3 plus 3 should equal 4 raised to the 5 times 3 minus 6. Well, this gets us 4 to the 6 plus 3, which is 4 to the 9th, should equal 4 to the 15 minus 6, which is also 4 to the 9th. So we want to just use that idea that if the bases are the same, then the exponents are the same. So let's look at another example. In this next example, you will not be given the same base on both sides. So 3 raised to the 4x plus 5, and we're going to set that equal to 27 to the 2x minus 3. So in this case, we need to look at the fact that we have 3, which we can leave alone, but we need to somehow convert 3 to 27. So what a lot of people want to try to do, a lot of people want to try to take the one side of the equation and multiply it by 3, and then they say, oh, well, 3 times 3 gets, or sorry, not 3, 9, and then they'll say, oh, well, 9 times 3 is 27, and then we can set the exponents equal to each other. That's not how this works. What we need to do is we need to convert. It's kind of similar to the idea if you went up to a vending machine and it only took quarters and you have a dollar bill, you need to convert the dollar bill into quarters. So that's what we are going to do. We need to somehow convert 27 to 3 to some power. So we're going to start making a list. 3 to the first is 3. 3 to the second is 9. 3 to the third is 27. Hey, look, we got what we want. So what does that mean? What we are going to do is we are going to replace the 27 with 3 to the third. So 3 to the third is going to go in place of 27. So that means 3 raised to the 4x plus 5 is equal to 3 to the third, because that's our value of 27, times 2x minus 3. Now, when we have two sets of exponents right next to each other, that means we're going to multiply them together. So 3 to the 4x plus 5 is equal to 3 to the 6x minus 9, because we do that distributive property. Now that they have the same base of 3, now that means that 4x plus 5 is equal to 6x minus 9. So then what happens here? Subtract the 4x. So we get 5 equals 2x minus 9, add the 9 to the other side, and that's going to get us 14 is equal to 2x, divide by 2, and our x value is 7. So now let's go back and check that out. So we get 3 to the 4 times 7 plus 5 is equal to 27 to the 2 times 7 minus 3. Which that means 3 to the 28 plus 5 would be 3 to the 33rd. And that should be equal to 27 to the 14 minus 3, which is 27 to the 11th. Why are exponents not the same? Oh yes, now I remember, because 27 is actually 3 to the third. Then 3 to the third to the 11th means 3 to the 33rd. And now they're the same because we have the same base. So again, we need to convert the bases to be the same before we can calculate any of the other values. Let's look at a second example like this. So this is a similar example, but with one small change. So we're going to look at 6 to the 2m plus 1. And we're going to say that is going to equal 1 over 36. So what's happening in this case? Well, I see a 6 and I see a 36, and I kind of know that relationship, but we have a fraction. So that means we need to go from a whole number to a fraction, that means we need to use negative exponents. So with our negative exponents, what we're going to do is we're going to create a similar list that we did before. So what is 6 to the negative 1? 6 to the negative 1 is 1 over 6 to the first, which is just 1 over 6. 6 to the negative 2 is 1 over 6 squared, which is, 1 over 36, which is what we're looking for. So that means we are going to put 6 to the negative second in place of 1 over 36. Now in this case, there's no additional exponent up there, so we don't need to do anything else with that value. But what do we know at this case? Once we have our bases the same, then that means our exponents have to be equal to each other. So 2m plus 1 should equal negative 2. So we subtract the 1 and we get 2m equals negative 3. Divide by 2, and the m value is negative 3 over 2. Now, a lot of times when people get a fraction, they freak out and they say, oh, no, we can't have a fraction. Oh, but you can't. So let's check this out. So we want to check out and see 6 raised to the 2 times negative 3 over 2 plus 1. What is that equal to? Well, in this case, it's nice. The 2's cancel out. So that leaves us with 6 to the negative 3 plus 1, which is 6 to the negative second, which matches up to what we are trying to find. So having fractions are perfectly fine. All right, now, in all these cases we've done so far, either the bases have already been the same, or we've only had to change one side. Now we're going to look at what happens when we need to do a little bit more. So 9 raised to the x plus 4 equals 243 to the x minus 1. Now, in this case, when we look at these, it doesn't look very straightforward. So what we need to do first is test and see, can we make 9 into 243? So 9 to the first is 9, so that's easy. 9 to the second is 81. And then 9 to the third would be 9 times 9 times 9, which is going to be 729. 729 is already way above 243, so that means if we were going to make this happen, our exponent would be some sort of decimal. Well, I don't want to calculate what that decimal is. So what is another way to do this? Well, let's think about 9. How else can we write 9 as a power? Oh, I get it. 9 can be written as 3 to the second. So let's look at powers of 3. So 3 to the second is 9, 3 to the third is 27, 3 to the fourth is 81, and 3 to the fifth, is 243. That's what we're looking for. So what we're going to do is we are going to make conversions on both sides. So that means 3 to the second to the x plus 4 is equal to 3 to the fifth to the x minus 1. So that's going to get us 3 to the 2x plus 8 should equal 3 to the 5x minus 5. We need to distribute out those values. So now that the bases are the same, that gets us 2x plus 8 equals 5x minus 5. So we can subtract the 2x. So 8 equals 3x minus 5. Add the 5 to the other side, which gets us 13 equals 3x. Divide by 3, and our x value would just be 13 over 3. Okay, that works. Now, let's check it out. So in this case, I'm going to check it out in the 3 to the 2 times 13 over 3 plus 8, where the distributive property has already been done. So this is going to get us 3 raised to the 26 over 3 plus 8. Now, in order to add those together, we need to get a common denominator. So the 8, we're going to change to 24 over 3. And that's going to get us 3 raised to the 50 over 3. Okay, now let's check the other side. So the other side is saying 3 to the 5 times 13 over 3 minus 5, which that means we would get 3 to the 65 over 5 minus 5. So, sorry, 65 over 3 minus 5, which would then get us the common denominator, 3 to the 65 over 3 minus 15 over 3, which also gets us 3 to the 50 over 3. Now, do you have to do all of this checking? Not necessarily, but it will tell you if you have the correct answer or not. So when you're done, go ahead and log on to the homework and do the assignment for today.